Today on Building the Open Metaverse.
There isn't just one metaverse. Everybody's view of what their digital twin and what the metaverse means to them is going to be assembled. So we had to think of something outside of what we were doing, and that we now call iTwinJS. It's our future for sure.
Welcome to Building the Open Metaverse, where technology experts discuss how the community is building the open metaverse together. Hosted by Patrick Cozzi from Cesium and Marc Petit from Epic Games.
Hello, everyone, and welcome to our show, Building the Open Metaverse, the podcast where technologists share their insight on how the community is building the open metaverse together. Hello, everyone. I'm Marc Petit from Epic Games, and my co-host is Patrick Cozzi from Cesium. Patrick, how are you today?
Hi, Mark, everybody. I'm doing great. I have a lot of reasons to be happy. This is the first episode that we're recording where I'm at the new Cesium headquarters. We haven't moved in yet, but it will have a full studio for recording podcasts. But right now I'm in our future boardroom. And for those watching on video, I have a printout of the Time Magazine Metaverse article that Matthew Ball kindly signed for us. Then I'm also excited because we have a very special guest with a great story to tell today.
Yeah, and our guest today is Keith Bentley, who is Executive Vice President, CTO, and co-founder of Bentley Systems. Keith, welcome to the show.
Well, thank you for having me. You have a very loyal audience, from what I understand, and I've seen some of your podcasts and some of your guests, so I hope I don't disappoint.
I doubt you will.
So, Keith, as you know, we love to start off the podcast asking folks about their journey to the metaverse. And, you know, yours is super special to me because, one, you've done it in the greater Philadelphia area, which is dear to both of our hearts. And two, I mean, you saw the opportunity for graphics and the PC before many other folks did. So we'd love to hear your journey.
Well, my personal journey and Bentley Systems journey started even before the personal computer. Back in 1984, we were founded, and our first product ran on I guess at the time it was called a mini computer from a company called DEC, Digital Equipment Corporation. Actually, our software ran on one of their OEMs from a company called Intergraph. Probably your audience may have been aware of. Anyway, the way our first product worked is you connected the VAX to a terminal called like a Tektronix 4014 terminal, and you sent graphics over ASCII using escape sequences. So that's the way our first graphics program worked. You use an RS-232 port to a terminal. Right around that time, the IBM PC AT came out, and it became pretty clear that the concepts of running software locally on a local computer had some advantages over the mini computer. A mini computer cost $1 million usually. The terminals themselves cost maybe between $5,000 and $10,000. And a personal computer was $15,000, maybe $20,000. So just price-wise, it was a huge advantage. But even more so was the advantage that you could, sort of have some autonomy. You were in control of your own destiny. Your computer was yours. That's why it's a personal computer. Anyway, so we wrote software that ran on the personal computer when it was relatively new. Our software did CAD, computer-aided drafting. So our graphics component, and there wasn't such thing as graphics cards at the time. There wasn't even such thing as network cards generally. And we wrote graphics that, turned pixels on bitmaps. And we wrote, shaders using painter algorithms and Brushingham algorithms. So at the beginning, it didn't do much, but CAD stood for computer-aided drafting. So our main mission was automating the process of creating pieces of paper, just automating that. Anyway, that was our first probably 10 years of our life. We enhanced the way that you could use your personal computer, and there was a lot of advances in the hardware. One of which was graphics cards. Ways that you could send not pixels to the screen, but commands to a GPU. That was kind of a new, cool idea for us. Then, kind of chapter 2 of Bentley Systems' story is that the CAD transitioned from being computer-aided drafting to computer-aided design. And the purpose of computer session would be not only to create pieces of paper, in the main still people-generated paper, but to create a model, an electronic model of some asset. So anyway, computer-aided design gave way over time to something called BIM. BIM, I think, the B stands for building, but IM stands for information modeling. And the concept is that instead of just doing, some modeling what something looks like, its physical properties, you also model the properties about why it exists. And so engineers use our products to design lots of things. They design roads, they design buildings, they design plants. Generally, we focus on the kinds of things that are large enough that they have a fixed location on the earth. So BIM is used to model now practically everything that is built in the built world, the infrastructure world, is modeled with some tool like ours or our competitors. I mean, many people work on this type of thing. Anyway, so the graphics components of a BIM model are typically designed around, trying to make a engineering representation of some physical property of things. And, the techniques for rendering and have advanced substantially, but in the main, people today still use BIM models to generate drawings, and drawings are not paper anymore; they're PDFs. But there's a much better approach to that coming, and the concept of a metaverse is really going to take over our business, the business of our users, and I'm really excited about what might happen next. For all the same reasons that you at Cesium and Epic are, we see it. It's going to happen. It's going to change. Just like the PC replaced everything about the personal computer, I think the metaverse, and we'll use the term digital twin, I think is going to replace our business in the not too distant future. It already is happening, and we're spending a lot of our effort on it. But that's kind of our journey. It's been nearly 40 years, so we've been at it for a while.
Wow. And I love the parallel to how game-changing the PC was and potentially how game-changing the metaverse will be today. We certainly feel the same way. I love the origin story, and I love that you were doing graphics in the greater Philadelphia area in the 80s. It was probably maybe a dozen people, including academics at that time. So I think it's very, very cool. And
definitely true. We started just down the street from where you currently are in Center City, Philadelphia.
Yes, yes.
Your office today probably is twice the size of the one that we had there. Bentley Systems began. I started it. Then I started hiring brothers. At one point, I had all four of my brothers working for Bentley Systems, so it's kind of a weird story. Bentley Systems is not a typical story, but one of the aspects that people tend to focus on is the fact that we were built by five brothers.
If I remember well, there was, at the beginning of the PC era, there was a lot of CAD companies. And only a few of them are still like 30-odd.
Right.
Why do you explain the longevity of Bentley over 40 years? What was the secret there?
Well, I don't know if there's any secret, but you're right. When we got started, the personal computer was new. Everybody saw that I think the only person who really wasn't convinced that the personal computer was going to amount to anything was the president of DEC, Ken Olson. He's a really smart guy and gets a lot of credit for a lot of really good stuff. But the only thing he's ever remembered for is his quote that, "Why does anybody want a computer at home?" Anyway, so there was a lot of people who saw that the personal computer was going to be, a game changer. And so literally there were 30 companies called CAD companies back then. And yes, Bentley, I think we have a few virtues that have made our journey one that's been sustainable. One thing was that we were profitable before we got started. So every month of our existence, we've made money, and that's fairly rare. So we didn't have to do lots of chasing of targets that were unattainable. So we kind of lived within our means for a while. But also, I think one of the things that stood us in good stead is, like I mentioned, the company Intergraph. They were the they were the CAD vendor of the day. They were a $1 billion company. They had a bunch of users that were initially our users because we sold them software that's compatible. And there's always a temptation in software to innovate and to kind of replace what you used to do with something better. And one of the things that Bentley Systems has done, and I think has stood us in good stead, is we've kept our existing users and only added to, kind of kept growing without replacing. So anyway, I don't know if there's a secret, but one thing is hire smart people, and I had 4 smarter brothers, so that helped me.
We all, usually on the podcast, Keith, we always ask for advice. So I'm glad you're already giving us some good business and recruiting advice.
Yeah, people sometimes come to me and say, "What's it like working with your brothers?" And I always say, "Well, I advise against it, but it's worked out pretty well for me." So yeah, we've managed to work together for a long time. There's only 2 of us left at Bentley, but that's a different story for our company. Is somewhat unique.
I want to call out that Bentley is an incredibly important company. Some of the major pieces of infrastructure, some of the things we rely upon in our daily lives around roads and large-scale infrastructures are being modeled, created, and operated using Bentley software. So it's not a household brand, but I think you guys have had an impact on a number of critical components of our daily lives. So thank you for that.
Well, don't thank me. I never brag about Bentley Systems. I only ever brag about what our users do with our products, which is pretty incredible. And you're right, some of the largest projects in the world, physical infrastructure. And one of the reasons the Metaverse has such a big impact on our, thinking going forward is the value that can be added by, modeling not just the way things are, but the way things might be. Think about climate change and all the reasons why we need to change our energy sources. There's just huge opportunities to do better in infrastructure, and it's been modeled largely, or a lot of it has been modeled using our tools. So we would very much like to be an enabler to make, using that information for the concept of a digital twin or the metaverse be mainstream. But it's not today.
Let's jump into this. I mean, you said Phase 2 of the chapter 2 of the Bentley story was BIM, and now chapter 3 is going to be digital twin and the metaverse. So you launched iTwin, a digital twin platform a few years back, actually, already.
Yes.
So can you speak to your motivation and your vision behind the product line and how you see the future of Bentley there?
Okay, well, the future of Bentley is around iTwins and digital twins, and certainly that's Keith's perspective on it. There can be lots of permutations on that theme, but I can tell you my commitment, I feel so strongly about it, was influenced by this guy I met about 5 years ago who showed me this product. Actually, he didn't show it to me. It was shown to me by a programmer in France who worked for Bentley Systems. Said, "Look at this really great stuff," and he showed me Cesium. And I looked at what Patrick and his team had done with Cesium, and I was just floored. Like, wow, that's in a browser. Like, wow, just imagine all of the models that have been created with our tools. So suppose you were actually able to use it inside a browser combined with lots of other data sources. I mean, one of the great strengths of Cesium is it does take data from many different formats and combines it together. And I said, that's what our users need. That's what the world needs, not just our users. The world needs to be able to repurpose information in lots of creative ways. And I was so amazed, not only about what it did, but by the fact that Cesium was open source. Like, it was brought to my attention by someone who worked for Bentley Systems and was using it for something I didn't even understand. Like, I didn't know why Cesium was relevant. Anyway, so I started thinking about, well, the future is going to be a world where data gets shared way more so than it does today. I mean, part of the problem today is BIM is a really great concept, but you need a BIM tool to read a BIM file. Largely, I mean, there's ways you can exchange it in IFC and so forth. But usually, the data is modeled by something that you have to learn, a tool you have to be really good at to be able to do wonderful things, to understand what's where. A, you need a license to it. B, you need training. C, you need the right version. And all those things combined just means that what people do today is they exchange information in PDF. So what a terrible outcome if we're modeling all this stuff and we have all kinds of BIM stands for information modeling, but if you export it to a PDF, you've just lost all the value in it. So anyway, what Cesium brought to me was, look, information should be exchanged not in some dumbed down format, but in a format where it could be live. And so I started thinking about, well, how could that possibly happen with our current generation of BIM products, Bentley's or anyone else's at the time? And I said, something different has to happen. So we started creating something we now call iModels, and open only because Patrick convinced me it was the right thing to do, or Patrick's work convinced me, it wasn't Patrick specifically, convinced me that information should be modeled in a way that you can repurpose it and reuse it by just downloading source code to a library that understands it without paying for a license, without having to, go to school to learn how to make it work. And see, you have to be able to glue it together because there isn't just one metaverse. There's, everybody's view of what their digital twin and what the metaverse means to them is going to be assembled in parts. So I thought, well, how can we be relevant for that? We can't possibly do it with our current desktop. Our generation of BIM tools was conceived before the internet, in the main. And so we had to think of something outside of what we were doing. And so we invented a whole new file format, a whole new persistence format. I guess I won't necessarily call it a file format. We could get into that, and also a new library that based on JavaScript, modeled after Cesium, in fact, using a lot of the Cesium code, and that we now call iTwin.js. It's our future for sure, and I think people will use it. Hopefully, will use it to build tools that do lots of incredible things that they won't necessarily buy from Bentley Systems, but Bentley Systems can be relevant for them. So anyway, that's kind of the direction forward. In 2022, I think we're maybe a third of the way through our journey from BIM to digital twins, but we are all the way into a third of the way behind us. There's a long way in front of us, but anyway, so it's a wonderful time. I wish I was Patrick's age because I'm so excited, and I'm more excited now. I have to say, I'm more excited now than I was in the PC. I saw that all the great thing, but PCs mainly they save money, right? You did the same thing but cheaper. In digital twins, it's not about saving money. It's about doing a better job and about, using new technology in different ways. People putting headsets on. It's not about just trying to do the same thing better. It's about doing different things. And anyway, so it's a great future, I think, for our industry. Certainly, I hope for Bentley Systems, but for all the pieces that, the people that can assemble this stuff. So if I was a young man, I would be starting my own company.
So, and for those of you who don't have a camera, looking at Patrick blush is actually a real company.
I give him a lot of credit. He deserves a lot of credit. But yes, I literally wouldn't be here talking about the metaverse if I hadn't seen Cesium 5 years ago. How long ago was that, Patrick? I don't know.
Yeah, it was about 5 years ago.
Yeah. Anyway.
That's an incredible story, Keith. Thank you for sharing this. So let's keep on talking about interoperability then.
Yeah. Well, okay. So interoperability, I think you can't have a digital twin or a metaverse of something that you buy from a single vendor. Like, it just seems so remote to me that anybody's going to constrain the types of information that they can model in their digital twin to being only available from a vendor or even a group of cooperating vendors. It's going to be assembled from parts that people will build. Now, there's going to be people that are experts in doing this, so not every digital twin user is going to build their own digital twin, but I believe there will be companies that are really good at pulling these pieces together. How can that possibly work? Well, in the world of open source, there are just so many pluggable tools that all build on the same technology stack that I think it is conceivable that you could assemble a digital twin from parts. Not if you have to go to school for every part, But, things like Node.js, I love it. It really does, to me, make the concept of open parts pluggable work really well together. JavaScript, game engines. These are all things that now are available and not, price prohibitive, not so hard to envision. Oh, well, I would have to, employ people that are experts in each one of them. I can be an expert at something that I really, I spend very little time because I'm familiar with the techniques it uses. So openness, I think, is an absolute prerequisite for the success in, well, certainly in infrastructure. I can't speak for, Metaverse outside of the one.
That's such a radical departure from what we've heard from CAD companies over the past 40 years. So I want to congratulate you for that, and acknowledge that, we have a lot of people coming to this podcast. People from the CAD world usually are not that blunt about it.
I can tell you there is no zealot like a convert, and I'm a convert because I was one of those people who said, free software. I pay programmers. How can I make free software? Okay, that was me. I said that. But now I say, well, look, yes, we have to have, or we're in this to make money. Don't get me wrong. I'm not, in this for charity. But I believe the sum of the parts is going to be so much greater when it can be plugged together. Then, people talk about vendor lock-in. That's one of the criticisms that people have against Bentley, against our competitors who will go nameless. But, vendor lock-in's real. If I were out there, I'd say, hey, if I use your tool, I don't want to have a subscription to your service to use my own data, right? That's insane. It's absolutely insane. Even if I promise you, like, oh, we're great guys, we will never rip you off, you might get mad at me for other reasons. And you need to have some, leverage. Hey, Bentley, we don't like your policy. We're gonna leave. If your data is locked up in our format, how scared are we? We or our competitors scared of that happening. But when we give you the tools to use your data without anything from us, now you have the ability to leave us. Hey, that's not a good thing for us. But what I think is we can prove that there's a lot of reasons why you should pay us to, provide you solutions. You can get tools, but we give you solutions. And I think we're going to win. I think if our platform takes off, our iTwin platform based on open standards like GLTF and all the other reasons why people will use lots of things that aren't from Bentley, we will be a part of an ecosystem that's going to be way bigger. So vendor lock-in, that's gone. One of the things I've told a lot of people at Bentley Systems who have argued against me on this is, look, suppose there is an open source platform and it really works well. What will happen? We will have to use it, right? We will be forced to interoperate with it. We'll try to sell you our proprietary thing, but you're going to say, yeah, but make it work with this open thing because I use this, little tool I bought from some third party. And I think we'll be so much better off, we Bentley Systems, but we, the industry, will be so better off if people have choice. So that's my position. That's not the first time I've said it. I've made that case to our users, in front of our users. I've made that case to our product managers, none of whom are particularly happy about the prospect that someone can use our platform without paying us. But I tell them the ecosystem is the thing. It's yet to be proven that I'm right, but I'm still pretty confident. Like I said, I'm more excited now than I was at the beginning of our CAD era. So vendor lock-in, you should, if any vendor tells you that the only way you're going to be able to use your data is with a subscription to their cloud, you should slam the door in their face. That's what I say.
That's a fair point. It's a pretty obvious thing, even though we know the industry practices tend to.
You brought up an important point. A lot of the infrastructure in the world that is modeled in our software is owned by government agencies, right? So they have a lot of concerns. Governments today are pretty concerned about, if I'm, an organization in China? Do I want to have software from a company in the United States? Or, do I want to have German software running on a American desk? Those kinds of combinations of things. These owners of infrastructure, they worry a lot about the 40-year, 50-year life cycle of the data that they're going to, digital twin is going to become something pretty valuable to their operations. Suppose they have their disaster recovery built on top of their digital twin solution. Are they going to listen to a vendor like Bentley tell them that, okay, here's how much it's going to cost you for the next 40 years? Like, we wouldn't be able to give them an answer to that if they want to. Anyway, they need flexibility. They want flexibility, and they need openness, and it's possible. And Patrick proved to me it can work well. So,
absolutely. So Patrick and I are part of an adventure called the Metaverse Standard Forum, and I think, the idea is to learn from, the USD open source library developed by Pixar and taken further by NVIDIA and propose a standardization of how you could compose 3D scene, which I think is exactly what you are describing as parts of digital twins. So I think there is a lot of convergence between those ideas, and probably that now is the right time to lay that foundation that we can assemble, virtual worlds or digital twins, from multiple sources, arguably in multiple formats into a single representation. So it's a very, very timely conversation and timely topic. So
So when you talk about the ways that people will assemble information from multiple sources, sometimes we like to point out that a digital twin of an infrastructure asset is going to have three main components. One is going to be just data that is observed, right? Reality data. People fly a drone, get a reality mesh, get a point cloud. That's a real important part of understanding what you have out there. Now, drones and LiDAR is only of what you can see. Then there's, below the ground, and there's ways that you can sense that. So that's, kind of the operational data, like what is there. Then there's sensors, like you connect ways to read current values of, how many cars are passing over this road, how much strain is there in this bridge. Connect a sensor, put a battery on it, put a transmitter to it. Now you can have this thing that has a basis in fact because you've observed it, connect it with what's actually happening, what the values of all the, not only the current values, but you can also look at the past values. That's all really cool. And sometimes people think of that as a digital twin, but then think about, what happens when you're going to propose a widening of that bridge or something like that? There's an engineering project that goes on, and that's where things get a little bit more complicated in our world than some worlds, because what you're actually doing is modeling the future, right? And the future is nonlinear. There might be 5 permutations on the way the changes are going to be made. You might want to model the construction sequence and like how do you get, from here to there? And those future states of the digital twin are just as important, right? And sometimes the future states of the digital twins are things you don't want to have happen. You model disaster scenarios, right? So the engineering model plus the reality model plus the real-time data, they're all really important parts. I don't know, that I would consider anyone more important than the other. But each one of them has a different requirement for persistence models, for visualization techniques. Sometimes you want ultra realistic representation. Sometimes you want schematic type representation. There's also drawings. A lot of information about why a roadway network is the way it is, or is in schematics, or Anyway, so the complication of like how you're going to get all this stuff to make sense to someone for a specific purpose is a very hard problem that I don't think any one vendor is going to be able to solve. So that's why I think, open standards for interchange, like, hey, we don't do GIS, but we recognize that a lot of people have a lot of real important stuff that they've saved in their GIS system, or their GIS system has the current state of a lot of stuff. We need to be able to, through things like Cesium, get the current, representation of that, draw it in ways that that our users can understand it, send it off to things like, Unreal to be modeled in real time and do a real nice job of simulating the way things actually look in the real world. Anyway, engineering plus operational data plus reality data is a hard problem that is enough. There's enough value to be added that 20 years from now we'll look back and say, my goodness, can you believe all they did was what we're doing today? It'll be really, really important.
Well, Keith, I love the open ecosystem philosophy and the idea that, look, we're going to grow the pie so big, then we can each be really good at a part of it, and interop, I think is a really great strategy. And I think that's what led to the success of the internet, right? As you step back and you kind of had silos of AOL or Prodigy, and then the open internet came with all the interoperability. So your philosophy is great, and Marc previously mentioned.
I don't know if it's great or not, but it's our philosophy anyway. Time will tell, right?
Well, this Metaverse Standards Forum that Marc and I have been involved in, just launched a few months ago, and it's up to like 1,700 or 1,800 companies, and the idea is, hey, this Metaverse thing is real and can be big, and we need to work together to facilitate and enable that interoperability.
Well, I'm cheering for you guys because I really think the more success the standards, formats have, the more data there is for all of us, and those of us who are working on trying to make it all work together. It'll help us, help our users, and help the world. I really think, the infrastructure. I have an infrastructure view of the world, and I'm worried that. We need to solve big problems, climate change,
absolutely.
Power generation, all those things. If somebody doesn't solve them, forget making money. We're going to not exist.
But talking about scale, I mean, you are led to solve some incredibly difficult problems around, for example, your context capture technology, which can scan large scale places. So. How far do you think we can take that capture process and how automated? Are you guys looking at machine learning technology? We've seen, a number of times. So what's your prediction on that?
Well, I'm always inspired by, examples of machine learning, cars driving themselves. And, we have some examples of just trying to reverse engineer, paper that has images of something that was, modeled either in 3D or 2D and try to regenerate it. And it works incredibly well. Algorithms are not the right answer. It's inferences that's going to be the long-term solution to those kinds of things. So I do believe context capture plus a lot of machine learning. There was a demo I watched just yesterday about trying to, get a digital representation of like a road surface and detect cracks, right? People do that today. They go out and, they look at it and they mark and okay, there's a crack there. But you can do it in real time. You could fly a drone, run a machine learning algorithm on the images from the drone, generate a 3D mesh, and then, determine that, okay, that's where we need to send a crew tomorrow. It's all possible today, or at least not all, but a lot of it's possible today. I really think we're at the very beginning of machine learning applied to, engineering type problems. And I tell our people, I think that's going to be Bentley's future, and for sure. I don't think we're going to be able to do it all ourselves. Like even in the crack detection world, you need experts. You need people that are trained at, making the models right. So the intellectual property, who owns that? I don't know. And I think there's going to be some, business problems around trying to make sure that the technology, people who add value get paid for it. But that's a nice problem to have.
What's your vision about making sure, because you mentioned, there's still twin have a component like a reality captured component and a parametric model. How do you keep those in sync? How do you make sure that your nuclear plant, your actual nuclear plant actually matches the digital model that you're going to use to do predictions?
Okay, well, that's the essence of our iTwin platform, I think. If there's one thing I think it does that we've never done before, and I don't think anyone else has addressed, is kind of change management. Think about the way software engineers work. We use Git, right? Git's purpose in life is to keep track of who did what they changed. You can roll the clock back. And as I mentioned, the engineering projects, they're always dealing with a future state, but it's not one future state. So there's one team working on one part. It moves at one pace. They, branch and merge just like we do in software. So the essence of our iTwin platform and something we call iModels is change tracking, change merging, and it basically is Git for infrastructure models. But anyway, that's kind of the essence of how to keep track of who changed what and what's the current state of something. But there's not just one state. I just want to point out there's not one state of the digital twin when you're talking about an engineering model. For example, sometimes people model what will happen after some catastrophic event, and they want to save that. They don't want anybody to use that in real time. That's not the current model. But if that disaster happens, they want to be able to bring it up instantly, look at what what has all the planning, how should it look, and who should do what. So anyway, planning for what might happen is part of the engineering problem. Storing that information in a way that you can get to it quickly, save it in the cloud. That's not an easy problem, but that's what we've worked on.
Yeah, it's the first time I hear this analogy with the software development process, and I think it's very relevant.
Another thing that's very analogous in software is, we will have different versions of our products, right? And sometimes we have to go back and make a change to an old version. Well, engineering projects, sometimes there's the plant currently being operated, and someone's got to go back out in the field and replace a leaking pump or something like that. And okay, you got to get the state of the model as of when it was actually built. That's not the state of the model where it's currently proposed. The plant is undergoing some transition, but you need to go patch. That's what we call it in software, and people do that in the real world. How do they do that today? They take sheets of PDFs out on iPads, and how do you know you got the right one? It's a mess. It really is. And furthermore, one of the wonderful things about Git for software developers is I have 5,000 source files. I changed 3. What did I do? Right? Finding change. And how does that happen in the world of engineering today? I kid you not. People hold PDF files up to the light, try to find what looks different. I mean, they don't literally do that, but it's all about trying to track change after the fact rather than keeping track of change and storing change. So that's what iModels do. We store change. We don't store the current state. We store deltas. Anyway, that's a brand new thing and a new concept for Bentley systems. It isn't the way the world in the main works today.
No, but taking that technology and that understanding from one domain, from the software domain, and then applying it, to infrastructure, I think is fantastic.
And you said you built iModel on top of an open source.
My favorite software product, number 2 is Cesium, but number 1, it must be said, that really opened my eyes is SQLite. SQLite, everything about iModels is built on the world's most open database. It's actually the world's most used database. More data stored in SQLite than all other data formats, all other relational data formats. It's a relational database in a file. It's written by mostly 2 guys. They put the whole thing in the public domain, and it works. I mean, it's a library. It's a C, not even C++. It's a C library that does full SQL, full transactions, and it works amazingly. If you don't know anything about SQLite, you don't have to understand how it works, but I guarantee you every one of your phones is running at least 5 copies of SQLite, including your mail application. That's the way all data is stored on mobile devices today. Anyway, we use SQLite as the persistence format for iModels, and we track changes through a tool in SQLite for keeping track of, which rows and columns were changed in a transaction. That's the way change tracking is done. So it's a really cool technology. I love SQLite. I'm a geek's geek, and I tell people, if you want to learn how to program computers, like if you're just getting started in software and you'd like an example of something that works really well, look at the SQLite source code. It's one of the best documented, best tested, most reliable source code. It's not a large code base. You would think that, how many lines of code is there in a SQLite or in a SQL engine, a query planner, and a transition? It's not that much. You can learn a lot about how to write good software by studying that. And I do. I look at it a lot. Patrick, I love Cesium, but I love SQLite even more.
I feel really good about Cesium coming in number 2.
Okay, all right. I didn't want to insult you.
But there's one other type of software that I wanted to ask you about, Keith, and that's game engines, right? So on this call, you mentioned Painter's algorithm. You're probably one of the few people I know who has implemented the Painter's algorithm. So
I'm proud of it. It's just the way we have to do it.
But through and through, you and your brothers are rendering programmers, right? Graphics programmers who rolled your own graphics engines early on. And then you've, at least to some capacity, adopted game engines for non-games, right? So I think these are, a really, really exciting area to talk about.
Yes. No matter what we would do, Bentley Systems, our mission is not being the experts at rendering. And if you look at what game engines now do, it's just absolutely amazing to me. I remember looking at them some years ago and being impressed, but, thinking, okay, well, that's not, we have all kinds of different problems. And sometimes in CAD, we don't want it to look real. Like we have, views where we show edges, and, it's not like realism is our primary goal. But all the time, our users want something that looks real. I mean, the more real it is, the better they can use to give presentations, for example. So we'll never be, like the rendering kings. We don't even want to be. In fact, so in our new open environment, I'm hoping people will use lots of different visualization techniques, Cesium for web form factors, game engines, not only for, physical devices, but it's just going to look so much better. It's perform better. It's really, really wonderful technology. And frankly, they make a lot of money selling games, so they don't necessarily need to price it out of reach for people to use for non-game applications. And so
some people do that.
Yeah, right. But anyway, so we're relatively new at that, I'd say. Our use of game engines, of the game engine technology stack, is nascent, but I see lots of opportunity for the combination of open standards plus a real quality rendering system that can run both in the cloud, on a mobile device. I just think that VR is going to be used way more when it works, and it works and is priced the way that people can use it on everyday projects. So we haven't done as much with game engines as I know that we will, but I really feel it's the right answer for a lot of problems that I don't want to have the Bentley Systems people working on. It's one of those areas where, if we combine efforts, both us and other people that will use that technology can create a solution that, neither one of us would be able to write on our own.
And we had the same observation with geospatial and applying that to game engines. And when we built the Cesium for Unreal plugin, like overnight, we made 30 years progress, right? When I saw this, to use the rendering engine and everything there. And I did consider myself like a hardcore rendering person, right?
Yeah, you teach it, right?
I'm like, wait a minute. I'm like, I can't keep up with this. So
and next year's game engines will be better than this year. It's a march that the innovation is always going to happen. So I feel like that's the kind of thing we can combine with and not compete with.
Absolutely. There are even some open source alternatives now. So
the technology stack that you would use to assemble, a solution today is like, imagine 10 years ago talking about using, a game engine. Like, how hard would that have been? The game engine vendors didn't think of it being used outside of the game, form factor. So they didn't put any work into making it possible for people to use it for other things. So anyway,
using JavaScript as a solid, computing platform.
Yeah.
10 years ago would have been a little bit.
You would have given up on that, right? You would have said, I got to write it in C or one of these compiled languages. And hey, I'm a huge JavaScript bigot now. Patrick convinced me of that too. I like TypeScript. I don't know, Patrick. You're not a TypeScript guy, but
not yet. Kip, we wanted to start wrapping things up with two questions. So first, there's probably a short list of folks that, if asked who I would want to model my career after, and I would name you as one of them. You have just incredible technical depth. I think you've probably written more code than me recently, which I'm quite jealous of. And then you've built an amazing company and business. So just for myself, but also for our audience, what career advice would you give for folks who want to be in the field?
Well, I'm a programmer, Patrick. I love programming. I'm only good at it. It's the only thing in my life that I'm any good at is writing software. I was lucky enough to get into this business at a time when there was huge opportunities. I combined with some really smart people and my brothers. So I wouldn't give advice to anybody other than, some people say, oh, pick a career you're good at and you'll never work a day in your life. I say, I've worked every day in my life, but I've enjoyed them all. So, what else can you look for in a career but to have done something you like to do? I've happened to also pick something where, it's been financially, successful for me, and I've been pretty happy with the outcome from that, but I'd be equally happy if I was able to do all this all over again and we, didn't make $1 billion company. But that wasn't the goal. So don't ask me for advice. I say, get lucky. And that's my...
I think that's part of the strategy. Yeah.
Yeah.
Yeah. Well, okay. I did get some advice when we were starting, and that was always hire the smartest people you can. And I do think maybe that doesn't apply in every business, but in software, there's a category of programmer who are able to, they see in code, you see a problem, you see a simple solution for it. There's other people that, they might be really smart at other things, but they see a problem and they try to make it hard, and software just doesn't come naturally to them. So in software, I think hiring the smartest people is always good advice. Making things simple is always good advice. So I don't know. Those are two things that I would say I know of.
I tend to agree with this. The productivity you get from those smart people, it takes sometimes entire teams to replace them.
Yeah.
The only thing you figure it out afterwards.
There is that. You worry too much about dependence on one individual. But anyway, there was a period of time in Bentley Systems past where we thought, well, you have N dollars, hire more people. You don't have to get the top, and that just never worked out. So smart people like to work with smart people, work for smart people. And you really have to make a team that, enjoys what they do and are really good at it, and they're not cheap. So anyway.
And our last question, although I think you've covered it already, is there a person, institution, organization that you would like to give a shout out to today that is not Patrick Cozzi?
No, okay, I won't blow Patrick's ego up anymore. But Bentley Systems is where it is because we had really, really good users. People did and do incredible things with our software. They've inspired us. When I go home at night, I think of, my goodness, I have a list of problems that one of our users might have. And I think to myself, man, that they trusted us. They thought that our tools were going to solve this. And if it's not working, I really want to help them. And then I look at what they do with it. I just think, my gosh, it's really cool that I could play a little part in that. So I always live in the reflected glory of the projects that people use our software for. So my first shout out would be to anybody who's ever bought something from Bentley Systems and used it to solve a real world problem. And then, of course, my new religion on open source. I won't mention Patrick's name again, but Richard Hipp at SQLite.
Mm-hmm.
He's the gentleman's gentleman, the best programmer I think I've ever met, and an inspiration. So I would thank Richard for his contribution to the world.
Amazing shout out. Thank you so much. So Keith Bentley, you created one of these big important CAD company 40 years ago with your brothers. What an incredible achievements that you've been doing, and now you have this newfound religion of open source. Dive deep into the metaverse and digital twin. That was amazing for you to share this with us. It's been a real pleasure to have you on the show. Thank you.
Thank you very much for having me. I believe in both of your missions, so I'm cheering for you guys. And like I said, I've listened to several of your podcasts, and you've had really good guests. So hopefully you'll be able to find something useful in what I said. All right.
And I think it's great that we get to expose, people like you, because as we said, the metaverse is going to contribute from a lot of people, and there's a lot of hard problems to solve. And I think some of those are being solved by you guys in Bentley. So once again, Keith, thank you very much for being there. Patrick, next guest will try to make you blush a little bit less. Okay? I'm not sure we can do this.
Sorry, Patrick. All right. Thank you very much for having me.
Yeah, and thank you very much to our audience. We hear lots of good things about the podcast. Keep on hitting us on social. Let us know what you think. Let us know who you want to hear from. And we'll be back with another episode soon. Thank you, Patrick.
Thanks, Keith. Thanks, Mark. Thanks, everybody.